Hi, thanks for taking the time to speak with me today.
Hello, Anna. It's nice to meet you. Welcome to the interview for the entry-level software developer position at Code Institute. I'm Ava, and I'll be guiding you through our conversation today. This interview will last approximately 20 minutes, and we'll cover various topics related to your technical skills, experience, and fit for the role. We'll start with an introduction, followed by technical questions, and then some behavioral questions to get to know you better. I'll also be asking you some scenario-based questions to assess your problem-solving skills and approach to software development. Let's get started. Can you begin by telling me a little about yourself and what motivated you to apply for this position at Code Institute?
Hi Ava, thanks again for having me in today. I'm excited to learn more about the role and how my skills can contribute to Code Institute's success. To be honest, I've been following your company's mission and values on social media, and I really appreciate the emphasis you place on innovation and community. As a beginner looking to break into software development, I'm eager to learn from experienced professionals like yourself and gain practical experience in a real-world setting.
It's great to hear that you've been following our company's mission and values, Anna. We're indeed committed to fostering a culture of innovation and community, and we're always looking for talented individuals who share our passion for software development. As an entry-level software developer, you'll have the opportunity to work on exciting projects, collaborate with our experienced team members, and receive guidance and mentorship to help you grow in your career. Now, let's dive into some technical questions to assess your skills and knowledge. Imagine you are tasked with fixing a bug in code you didn't write. What steps would you take to understand the code and fix the bug?
That sounds like a challenging scenario, Ava. If I were stuck on this code, my first step would be to review the documentation and any relevant logs or error messages to get an idea of what's going wrong. Then I'd try to reproduce the issue myself to see if it happens consistently. Next, I'd search for similar bugs or issues in our repository or online to see if anyone else has encountered the same problem. If that doesn't yield much progress, I might reach out to a more experienced dev on the team via Slack or email to get their input and guidance on how to tackle the issue.
That's a great approach, Anna. Reviewing documentation, reproducing the issue, and searching for similar bugs are all essential steps in debugging code. And don't hesitate to reach out to more experienced team members for guidance. That's exactly the kind of collaborative and supportive environment we foster at Code Institute. It's also important to be willing to ask for help when needed, as it shows that you're proactive and eager to learn. Now, let's move on to another question. Can you explain the difference between a for loop and a while loop? When would you use one versus the other?
So in Python, I think there's a distinction between for loops and while loops. A for loop is used when we need to iterate over a sequence of items, like a list or tuple. It's typically used for looping through data that doesn't change during execution. On the other hand, a while loop is used when we need to repeat some code as long as a condition is true. If I had a variable that kept changing value and needed to be processed at least once, I'd use a while loop. For example, keep running this process until it finds what it's looking for.
That's a great explanation, Anna. You're absolutely right about the distinction between for loops and while loops in Python. For loops are ideal for iterating over sequences, where you know the number of iterations in advance, whereas while loops are better suited for situations where you need to repeat a block of code until a certain condition is met. Your example of using a while loop to process a variable that's changing value until it finds what it's looking for is a perfect illustration of this. It's also great that you mentioned the suitability of each loop type for different scenarios. Now, let's talk about a project you've worked on. Describe a project you worked on, either in school or on your own, where you encountered a significant challenge. How did you overcome it?
One project I worked on during my undergraduate degree that comes to mind was building a simple game using Python and the Pygame library. One of the challenges we faced was optimizing the rendering of the game elements, specifically the sprites. The issue is that no matter how many iterations we ran through the loop, the rendering of all the sprites would still take up almost an entire second of CPU time due to the repeated calculations involved in updating their positions and colors on screen. We wanted to optimize this process as much as possible, but it seemed like a huge task. To solve this problem, I decided to use a combination of techniques such as caching sprite images and using a more efficient rendering algorithm that took advantage of multi-core processors by processing multiple sprites at once. It was a challenging project, but with the help of some friends who shared their knowledge and experience on the topic, we were able to overcome it and create a significantly faster game.
It sounds like you and your team encountered a classic problem in game development, Anna. Optimizing rendering performance can be a significant challenge, especially when dealing with multiple sprites and complex calculations. I'm impressed that you were able to overcome this challenge by using techniques such as caching and multi-core processing. It's great that you were able to collaborate with your friends and leverage their knowledge and experience to find a solution. This kind of collaboration and willingness to learn from others is exactly what we value at Code Institute. It's also excellent that you were able to think creatively and apply different techniques to solve the problem. Now, let's move on to another question. Tell me about a time you had to learn a new technical concept quickly. What was your approach, and how did you ensure you understood it?
I recall a situation where I had to quickly learn a new programming language, such as Java or C#. I had been assigned to work on a project that required writing code in this language, but I didn't have prior experience with it. My approach was to start by reading the official documentation and tutorials provided by the language's creators. Once I understood the basics, I then began experimenting with simple programs to get familiar with the syntax and data structures. I also tried to find online resources and forums where others were answering similar questions. To ensure that I understood the concept correctly, I broke it down into smaller parts and tested them independently. For example, if I was trying to understand a complex algorithm, I would try to apply it to different scenarios or use code snippets from various sources to verify my understanding. It wasn't until I wrote a simple program that successfully executed the logic that I felt confident in my knowledge of the language and its concepts.
It sounds like you have a very structured and effective approach to learning new technical concepts, Anna. Starting with official documentation and tutorials is a great way to get a solid foundation, and then experimenting with simple programs to get hands-on experience is excellent. Seeking out online resources and forums can also provide valuable insights and help you learn from others who have already worked with the technology. Breaking down complex concepts into smaller parts and testing them independently is also a great way to ensure you understand them correctly. And finally, writing a simple program to test your knowledge is a fantastic way to validate your understanding and build confidence. It's great that you're willing to take the time to thoroughly learn and understand a new concept, rather than just trying to rush through it. This kind of dedication to learning and self-improvement is exactly what we're looking for in a candidate. Now, let's talk about object-oriented programming. Can you describe the concept of object-oriented programming, or OOP, and some of its core principles?
I'm glad you asked that question because it's one of my favorite topics.
Object-oriented programming is a
Object-oriented
programming
programming
paradigm that
OOP is a
revolves around the
paradigm that
concept
revolves
of
around the idea of organizing code into objects that contain data and functions to manipulate that data. The key concept in OP is encapsulation, which means bundling data and methods that operate on that data within a single unit.